All right, law of cosines, given A and B and gamma, we'll find you C. So this is a side angle side problem. So, okay, what we do is we draw this triangle with sides A and B in the coordinate plane, angle gamma here. This goes out distance B to the point B by 0. This is at a distance A at an angle gamma. So this point here is A cosine gamma by A sine gamma. C is the distance between these 2 points. And okay, Pythagorean rule, the distance formula. C squared is difference of x's squared, A cos gamma minus BL squared, plus difference in the y values squared, A sine gamma minus 0 squared. Okay, we square this binomial to A squared cos squared gamma minus 2AB cos gamma plus B squared. The 0 drops out and you just get A squared sine squared gamma. Now, these two terms both have an A squared, and it's times cos squared and times sine squared. So we factor it out. A squared times cos squared plus sine squared gamma here, plus this B squared here, minus 2AB cos gamma here. But cos squared plus sine squared is always equal to 1. So we get C squared equals A squared plus B squared minus 2AB cosine gamma. And that is one version of the law of cosines. And again, when we swap around the labels, A to B to C to A, alpha to beta to gamma to alpha, and take square roots, we'll get A equals root of B squared plus C squared minus 2BC cos alpha. B equals root of C squared plus A squared minus 2CA cos beta. And C is root of A squared plus B squared minus 2AB cos gamma. Okay, these are 3 versions, of course, of the same identity, the law of cosines. And this solves a side angle side problem. Given 2 sides and the angle between them, what's the opposite side? And now, if we pull this back and square both sides, A squared equals B squared plus C squared minus 2BC cos alpha, and then solve for alpha. Well, we transpose this to the right, left is transpose this to the right. We divide by 2BC and we take an arc cosine. And then from that, we get alpha equals arc cosine of B squared plus C squared minus A squared over 2BC. And if you swap around the labels, beta is arc cosine of C squared plus A squared minus B squared over 2CA. And swapping more, gamma is arc cosine of A squared plus B squared minus C squared over 2AB. The general rule is angle equals arc cosine of the square of the sides not opposite it minus the square of the side opposite it, all divided by twice the product of the sides not opposite. Now, the book doesn't give this a name, and in fact, I don't think it even elucidates this theorem. But I think it's useful enough in its own right to deserve a name of its own. So I call it the law of arc cosines. So the given 3 sides, find the 3 angles. Okay, here we go. And let's hope I didn't mess this one up. Sides are 6, 5, and 8 for A, B, and C. What are the angles alpha, beta, and gamma? Okay, alpha, arc cosine of B squared plus C squared minus A squared over 2BC. That's B squared is 5 squared, C squared is 8 squared, A squared is 6 squared over 2 times 5 times 8. That comes out to 48.5 degrees about. Beta, arc cosine, the adjacent side, C squared plus A squared, minus B squared over 2, the adjacent side, CA. Arc cosine of 8 squared plus 6 squared minus 5 squared over 2 times 8 times 6. That comes out to 38.6. Now, I could, from here, subtract these from 180 degrees and get this value, 92.9. But personally, I prefer to use, so to speak, fresher ingredients. I always use the original information whenever possible, rather than derived quantities, because when you derive a quantity, errors may accumulate. So gamma is arc cosine of, let's see, 6 squared plus 5 squared minus 8 squared over 2 times 6 times 5. That comes out to 92.9 degrees. So we've solved this triangle. Here they have, it's a navigation problem. An airplane goes 150 miles north, then turns 50 degrees towards the east and goes 100 miles. And so the question is, how far did it go at what angle? It's distance and bearing. All right, well, D is easy enough to find. Okay, first, if this is 50 degrees, and this angle inside is 130 degrees. So we have 150, 130, and 100. So D is the square root of 150 squared plus 100 squared minus twice 150 times 100 times cosine of 130. Push the few buttons, bingo. D is about 227.6 miles. Now to find gamma, well, we have the three sides, 150, 100, and 227.6. 150 and 227.6 are the adjacent sides. 100 is the opposite side. So to theta, apologies. So theta is arc cosine of 150 squared plus 227.6 squared minus 100 squared over 2 times 150 times 227.6. Churn, about 19.7 degrees. So the airplane, as a net result, went 227.6 degrees at a bearing of 19.7 degrees east of north. Now, B is 1, C is 3, alpha is 80 degrees. What's beta, what's gamma, what's alpha? What's A, excuse me. All right, A, root of B squared plus C squared minus 2BC cos alpha. 1 for B, 3 for C, 1 and 3, 80 degrees for alpha. Push the button, about 2.99301, and I suppose that's way too many decimals accuracy, but because really these don't have any decimals at all, so maybe I should say 3, but no, 2.99301 is more than enough, and I'll keep that. So we have three sides, 1, 3, and 2.99301. So beta is arc cosine of A squared plus C squared, 3 squared plus 2.99301 squared minus B squared, that's 1 squared, over 2 times 3 times 2.99301. Push the button, about 19.21 degrees. Gamma, arc cosine of, well, okay, A and B are the adjacent sides, C is the opposite side. So it's arc cosine of A squared, that's B squared, that's 1 squared. A squared is 2.99301 squared minus C squared is 3 squared over 2 times 1 times 2.99301. Push a button, about 80.79 degrees. That makes sense. Alpha was 90 degrees. These are both about 3. This is almost 3. So these two side angles should be about the same, and they are 80 degrees and 80.79 degrees. Okay.